Assalamualaikum. Today we would be learning how to convert BCD code to access3 code. So first of all, this is a proteus 8 screen. To um, go for the sub implementation, I would first of all open the project as I've also already created it. Go to the place I've saved it. I've saved it with the name of classwork DLT. So I'll open it. Okay, so here is my project. Okay, so in this I've used BCD to access 3 code by using mux, also known as multiplexers. Now, what is the major difference between multiplexers and decoders? Multiplexers, and the basic difference between multiplexers and decoder is that multiplexers have only one output, whereas mux has only one output, whereas decoder have multiple outputs. In this, I've used 4x1 muxer with 4 inputs, that is A, B, C, D, and 1 output. These rest are its simulation parts. Okay, so let's start with it. So I've arranged them, and I'll be further explaining in the video ahead that how have I numbered these project gates. Okay, if you would simply just join these 4 with the probes and do not join these remaining, it would not be giving you output, because these are where the function is implementing. So first of all, I will be explaining my circuit. So I have placed 4 muxers here, multiplexers here, and this they have 4 outputs. That is W, X, Y, and Z, with 4 inputs A, B, C, and D. So to further resolve it, I'll be getting it little bit down so you can I could explain it further, so it would be easy for all of us to understand it. Okay, so I'll be dragging them alongside downwards. So this circuit would be a little bit neater. Oh, now I'll be going back up. Okay, so there are 4 inputs: A input, B input, C input, and D input. Now I'll also name them C input. Okay, to further explain it, this is C. Oh, sorry. This is B. Okay. Uh, okay, sorry. Okay. So whenever you're making a circuit, make sure that whatever sheet first of all you take, it should be having this in an, it should be according to your circuit. Okay, so I don't know why it isn't. Yes, so A. Okay, so now I've named all of them like A, B, C, D. So now I'll be naming them as well, the logic props as well. This is W. Okay. This one X. This one is Y. And this one is Z. So I have to move them down because they're a little bit up and you cannot see the symbols properly. Okay, so you can move them down, but just make sure that it shouldn't be colliding with the circuit or it shouldn't be colliding with any of the wire for a perfect design and a better implementation. I'll then rearrange it so I can get a possible neater look so I could explain, and also to the person who would understand it. Okay, so let's get started. Okay, first of all, these are simply IC just joined here with one. It is not joined with multiples one, so it is a simple one circuit. Then these A is joined with the A part. You can, if I just select it, you can see it is joined with the A part that is coming here. This same part, and this A is also being joined with this A, and this A is also line is also be joined with the would be and ZA. Then the same goes for the B. As you can see, it is joined with the B here, and this B is also joined with this B, and this B is also joined with this B and also with this B. Now I'll be explaining the circuit using our one and only truth table. So so first, in the first part, I showed you the PCB of the proteus stimulation of this circuit, but now I'll be explaining it by its truth table. So here we have four inputs A, B, C, D, as you were having in the proteus circuit, and four outputs, that is W, X, Y, and Z. So first of all, then complementing A as 8, B as 4, C as 2, and D as 1, as we use in digital logics. Similarly, W as 8, X as 4, Y as 2, and Z as 1. Now I will be explaining it here further. Now in X3 code, we derive it with a plus of 3. So that means that if we have BCD codes from 0 to 9, then in X's 3 we would be plusing it with 3, which would be including 3 to 12, which would be leading it to 3 to 12 elements. Now how would this be doing? As the name initializes 3, that whatever the excess number written ahead with it, it would be added into the BCD number that is coming in. So if we are having 0, then 0 plus 3 is equals to 3. That means 2 plus 1 is equals to 3. That would be giving us Y and Z are both uh, high, and they are both open gates. Then if we have the second element and we have 1 as an output in BCD, then 1 output plus 3 is equals to 4. That means X is 1 open and X element would be showing. Similarly, if we having 2 here, so this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And likewise we having here plus 3, so 3 plus 4 plus 5 plus 6 plus 7 and plus 8 plus 9 and plus 10, then plus 11, and thus then plus 12. That would be exceeding us to XS3 code. That would be I would be further explaining in a in our PCB, that how this input is specified and is giving us a proof of it. Now going back to the circuit, first we have to explain it, that what happens when we go to the truth. Now I'll be explaining the outputs present over here. So first of all, I will be turning off all of them as 0. Okay. All the inputs A, B, C, D are 0. We get output as last two as positive. This one was 8, 4, 2 and 1. So the first output when all the inputs are 0 should be 3. 2 plus 1, and that is absolutely explained. Then we get the last one as positive, as 1 is positive. Then we get 1 is positive, that is 1 plus 2, 3 is equals to 4. Means second output is positive, and that is absolutely explained here. Then we get C is positive, that tells us that 2 plus 3. 2 plus 3 is equals to 5. That is 4 plus 1. And that is also explained. Similarly, we would be going ahead and we would be explaining this very proficiently. Now, if we say, for the example, we would be saying it that we want 4. 4 plus 3 is equal to 5. 7. Now, 7 is 4 plus 2 plus 1 is equals to 7, and all these three inputs are positive. So this we just have to follow the truth table and it would be resolved here. And that explains that our multiplexers is also capable in following in application of BCD code to access 3 code or any other example. Now, why do we use these multiplexers here? Multiplex or mux are efficiently used in the circuits where we need only one output with each the multiples of inputs. That will simplify the circuit and also give a variety of chance of us to use extensive amount of uh, signals, so that extensive amount of output could be generated with much simpler versions. Jazakallah, and thank you so much.